Thank you very much. I know we are short of time, so I'll try and keep it quick. Vern has already introduced me, and I think we wouldn't be talking about data science, machine learning if we didn't actually start with data, right? When we talk about big data, how big is big? So this is a question that my son asked me the other day. And as I was trying to figure out the answer, I'm sure a lot of you have gone through this process, right? We started with kilobytes and megabytes and gigabytes. And these days we're going into tera, peta, exa. We're going into bytes we didn't really know existed, right? So one followed by 24 zeros is a yottabyte. That's right, a yottabyte. But here's the interesting thing. Do you know what is one followed by 27 zeros? This was a topic of conversation a couple of years ago because people thought, oh, we don't really know how to name this thing. So the name that was collectively decided upon was a brontobyte. So one followed by 27 zeros is a brontobyte. There is a lot of data that is being created at the moment. But more closer to home, the topic that we're discussing today, capital projects, we create a lot of data as well. Let me show you what I mean. So what we did was we spoke about Oracle Aconex at the start of the session and just before. So we said, can we visualize the information that is created in one Aconex instance? So what you see on the right-hand side is an example of such a visualization. So each dot there is an organization exchanging information with other organizations. Information such as documents, correspondence, workflows, RFIs, transmittals, you name it, right? And this is from one Oracle Aconex instance. And over the years, there's so much data that is exchanged that's kind of mind-boggling when you look at it this way. But you know what? Sometimes it's easy to get carried away with all the coolness. And you've got to remind yourselves, at least I do, that construction is one of the oldest professions in the world. And, I've got some pics just to keep me grounded and real. And these things did not have data and machine learning. And, they still stand the test of time. And what's really interesting is that 2000 years ago, Julius Caesar had Vitruvius, who was called the chief engineer of the world, that wrote a 10-volume treatise on Roman construction practices. They talked about construction risks, which inherently exist in the process, which is something that we did in our poll just at the start of the session. They talked about this 2000 years ago. They talked about careful contractual articulation. So some way to think about this is all that thing that Alan was talking about with Aconex control, a connected cost and P6, there was some level of thinking along those lines 2000 years ago. And here's some text around it, right? They're talking about disputes and drawing up contracts that need to be skillfully drawn. It's quite amazing that the topic is old, and yet we have issues like what I refer to as the 3Ds of construction. Now, this 3D is not geometric design, which would be quite exciting, or a BIM. The 3Ds I'm referring to are delays, defects, and disputes. You pick any research on construction and you will see numbers like this. 35% will have a major change. 30% of the data is lost. 82% need more collaboration. There's project risks are increasing. Firms are prioritizing immediate financial goals, and construction dispute lengths go for about 17 months. Now, these numbers aren't important in themselves because depending on the report you pick up, they will show you different things. What's really interesting is that these numbers exist after all these years. And it makes sense because if you kind of peel and look under a project, you will actually see what's happening. And that's what we did. So we know there's a lot going on. So we thought, let's understand what are the issues that the industry faces, and then we will peel under a project and take a look at it. So often the problems menu looks like something like this. So on the schedule front, you have delayed projects. Cost, we were just discussing that. But often when that is not managed effectively, you have cost blowouts, margins are poor, estimates are not right, ineffective contracts. Quality is a big issue. There's quality in terms of the materials, often requiring rework. Safety is a big deal, incidents, near misses. and in general, risk management, identification, mitigation, and response. And you look at this and you go, these are things that literally most capital projects around the world care about, right? And yet they are hard because this is what happens inside a project. So what we did was we said, for a 3-month period, let's see what happens within a project. As you can see, there's architects and main contractors and subcontractors. And we said, let's see the exchange of information. So the little circles you see, these are transmittals. And each transmitter has about 7 to 8 documents. There is a lot of information exchange going on. And this is obviously reduced to scale. So when there's so much of information going on, the chances of something going wrong are pretty high. And this is where I think we need to think about how we use all the new age technologies and tools to solve the problem. I think the industry has responded to this with what I call as the Asian revolution. So Asian basically is denoting an action, and you will see what I mean. There is some form of standardization going on. You're standardizing internal processes or your supply chain partners. There's prefabrication, modularization, integration both within systems or vertical integration of your supply chain, automation of business processes, systematization. There's new systems being implemented, like some of the examples we were seeing before, and a lot of collaboration, right? And as you see here, I call it the Asian revolution because there is a lot of Asianing and actioning happening here. And what that leads to here is digitization, right? So with COVID, a lot of the standard business functions are now getting digitized. There's new technologies, new solutions that are being implemented. And with this digitization, there is datafication because each of these digital solutions are creating data that we never had access to before. And what that is leading to is reimagination because you're going, oh, I can change this business process in a way that I had not imagined before. And that fundamentally leads to transformation. So transformation of the business process, transformation of capital project delivery, transformation of the organization. And that's perhaps what drives innovation. But when you look at this, and I think a lot of people know that construction was kind of a digital laggard and it was just placed above hunting and farming a couple of years ago in a McKinsey report. So sometimes people argue that transformation is long overdue and the innovation needs to be a radical innovation. It's not a step change. And that's why today on construction sites around the world, you see technologies like this. And some of this technology was first discovered in the movies, like, AR and VR, like Tom Cruise in Minority Report, autonomous vehicles like cars, wearables from Inspector Gadget, robots from Transformers. And you can think about Hollywood and you can think about a construction site and you go, wow, I've seen this before. Here's one from our own. So we're building the Innovation Lab in Chicago, and this is Faro Spot doing a field inspection. There is a lot of tech and a lot of tech creating a lot of data. So what's interesting is that all of the data that's being created is changing the perception of what we know as data. So think about this. 20 years ago, or perhaps 25 years ago, when we talked about data, this was the mental model most people had. Tables and relationships and primary key and foreign key. We call it an ERD, an entity relationship diagram, and we still have them. But today we show these kinds of examples, and this is still data being exchanged. This is exactly what I showed you right at the start. And this is data between different organizations delivering capital projects across 7 or 8 countries. It's become an art. So what we set out to understand was there's a lot of data and there's a lot of risk. So what happens when the two collide? Data, risk, and what if you were to capitalize on the opportunity? Because right at the start, this group also decided that risk was perhaps a big focus that often gets neglected. So we asked these questions. How can we accelerate data-driven decision-making? How do we use new emerging tech like artificial intelligence and machine learning? And the focus is not so much on the tech as opposed to the value that it provides. How can we simplify the provision of actionable insights and intelligence? And again, portfolio and project reporting was something that was picked up right at the start in the polls. But how do we rethink the status quo in a post-COVID world? There's a lot of data, risks are increasing, things are getting fragmented, there's a lot of digitization and a lot of datafication, right? How do we bring it together? So one of our solutions that we recently introduced into the market is a solution called Construction Intelligence Cloud. It's an AI advisor. And what we thought we would do is use all of the data that we have within our products and quite timely around P6 and AACE-ZA to solve some of these problems. So for the rest of the presentation, what I thought I will do is give you examples of how we're trying to solve these problems through this solution. And at the end of it, we may not have time for question and answers, but you can always reach out to me directly on LinkedIn or contacting Verna. So the first and foremost question is are we ready? Like, we're still struggling with reporting and analytics. Are we ready for AI? Well, the AI term is pretty loaded, right? But we already use it in our day-to-day life. So think about movie streaming, the recommendations, online shopping, music, predictive text. It's already there, weather forecast. So we are already using it in many, many different parts of our lives. So why not construction? Why not capital projects? So with that in mind, think about this. If we did this right, we could do the following. We could plan smarter, and I'll give you some examples of what that means. We could predict risks, and this is a big one. So the ability to predict what might happen that isn't necessarily in a risk register. How do we prevent issues from happening before they happen? And how do we deliver faster, better, easier, because you achieve all the financial outcomes? But you have safer job sites, so there's less incidents and happier customers, happier employees. And I think that bit, the human element in AI and machine learning and data, should never be lost. So let me start off with an example. So first and foremost, we're thinking about minimizing schedule delays. So for all of you that are working on a project at the moment, think about these questions. Is the schedule built right, and does it have errors? What is the probability of delay on your current projects, and how many days will the project be delayed by? Now, a lot of customers have different ways in which they measure probability of delay. But if you don't, that's a good starting point. What is the probability of delay, and why am I thinking about delay? I hope it's going on time. What activities are predicted to be delayed, and by how much? And what factors are contributing to the delay? What are the sources of delay? And how accurate are they? So fundamentally, our first use case, if you will, is answering the question around, is my project going to be delayed? And how do I use AI-powered predictions to take preemptive action and keep the schedule on track? That's our first use case. So let me jump into some examples from the actual Construction Intelligence Cloud Advisor application, so you can actually see it because it's far more powerful. So you see a screen like this, which says the chance of delay on this project, for example, here is 65%. We look at 71 different factors and we highlight the ones that are causing the prediction. For example, we might say, well, you don't have enough activities here, or you haven't factored that stage of the project, you haven't assigned the right level of resources. A whole bunch of different things go into delay predictions. And we want to highlight the activities that have the largest prediction for delay, because you get to see a tree map. Now, a tree map like this is quite powerful because it shows you where you might need to focus your attention on. It is saying that here are the activities that are delayed, and here are the activities that are predicted to be delayed. What's interesting about this and changing the status quo is you're thinking about prediction and delay right after a schedule is created. You might have not even gone on site, but we are already thinking about delays. And this is really, really important, because what we want to be able to do is proactively manage every step of the process and always think about delay even before the project has started. But when you see here are the activities that are predicted to be delayed, you can start to dig into that. Oh, this particular activity might be delayed by 34 days, as in this example, and that can pretty much be a big issue. What it can also do is show you what the downstream impact might be. What I'm showing you here is a non-traditional view of a Gantt chart. It is a network view. Often what happens with a Gantt chart is sometimes you'll have to scroll, and when there's many different activities, it might be hard to understand what a downstream impact might be. So what we're doing is reimagining how we think about schedules from a perspective of delay. So when you know this particular activity is delayed, you can very quickly understand what else might be delayed because of it. What are the downstream impacts? So again, the whole idea here is to be one step ahead. Always think about delays, always try and mitigate it before the delay happens. Let's go into another use case. A lot of customers and a lot of contractors and owners have a lot of data. Do you learn from the past data? Do you ask questions like this? Is the quality of schedule comparable to industry standards? How does your current project schedule compare to what was done previously on your good projects, on your not so good projects? What were the most delayed activities and which activities were delivered ahead of time? And who are your best and worst performing supply chain partners? Now, this is in AI, this is in machine learning, but the simple idea of using historical data to learn from the past and make changes to the present is quite powerful, because that will help you uncover a lot of things. Some examples here might be, you create a project group where you say, I'm going to create a project group of my best performing projects and my worst performing projects. And I will be able to then share how the current project compares to historical project. I can compare it on a whole bunch of different metrics like this. And I won't go into each and every example here, but the idea is that you're constantly comparing your present project to historical data and showing what might happen on this project compared to what has happened in the past. The other really interesting thing here is, if you're all thinking about how are you actually making predictions, what we're trying to do is we are not only making predictions, but we are enabling organizations to think about predictions without making data scientists out of all of them, right? So we're answering questions like, how do you improve the quality of your predictions? How do you train and learn off your current data? And how do you know what is important for predictions, right? How can we use different models for predictions? And how do we enable everyone in the organization to use these predictions? So think about it like this. We're thinking about simplifying machine learning so that it is easily accessible, so that everyone can access it. Here is an example from that particular idea, where the way we explain machine learning is we're looking for patterns and you decide what goes in there. So if you can pick a value from a dropdown, if you can click a box and you can press a button, you're ready to go. We want to make sure that the data science that we're talking about is accessible so that a lot of people can use it without needing to understand the underlying complexity. The other big use case here, and we were talking about Oracle Aconex, is trying to uncover hidden risks. So think about this. Could this project end up in disputes and litigation? Is there a risk of rework on your project? Are there signs of health and safety issues? And is there an unexpected change request that's going to come and cause havoc? And are there partners that are causing fragility in the network? And I'll explain what that means. But fundamentally, what we're doing is we're using concepts like NLP and other AI and machine learning technology to look at unstructured data, to look at text, and try and make predictions around what might happen. So let me give you an example. This is the Florida International University, a bridge that collapsed a couple of years ago. And just before it collapsed, there was a lot of text that was written where people were talking about the growing cracks. There was emails that were discussed. What if we were able to pick these up? What if we were able to surface the insights to the right people and prevent a bad thing from happening? That's basically the concept, right? We're using natural language programming and other data and text analysis from an AI and ML perspective. But the idea is we're using text to try and surface issues before they happen. So let me give you an example. Back in the day, we spoke about WYSIWYG, which is an editor in the software engineering world. And WYSIWYG stood for what you see is what you get. But there is another aspect to this. What you don't see will hurt you, WYSIWYG. Let me give you an example. So all the little circles I showed you at the start of this process Are people exchanging documents and transmittals? They're talking about these things, documents and change and details and street and all of these things. But what you probably can't see clearly from this screen is this. There are little reds that are going around where people are talking about prosecution in court and legality, things that are happening that people are raising concerns about, but it gets lost in the noise. So how do we separate the signal from the noise? How do we pick things that are important from a health and safety perspective, from a dispute and litigation perspective? So some screens here are focused on that. So we want to be able to say, here are the risk hotspots. Here's where the risk is coming from. And it uses Oracle AACE data. So the idea of using machine learning to be able to uncover risks, something that we identified right at the start of this session, is something that we are really, really passionate about and we think will make a big difference. And the fragility of the supply chain. So, I've been showing you these little fancy looking connected supply chains, but what does yours look like in your current organization? And how do we make it easy for you to be able to see that? It's answers like this that we want to be able to provide in our new solution. But really, this is about three things, right? It's about trying to get to zero on health and safety incidents, disputes and litigation, and cost overruns. But it's also about accurate estimates, creating successful jobs, delivering projects on time, and exceeding expectations. Now, you're probably looking at that and thinking, Dion did a great job of talking about the change. And we get that. This is us from 1997 and the good old floppy disk that most people don't remember. So I think the key thing with any of this is to think about the data cycle, right? Where is the data being created at the moment? It often is in a system like Oracle AACE or Primavera P6 or Microsoft Power, SharePoint. Think about how you're collecting that data in a database, data warehouse, how you're consolidating it, bringing all of this data together, and how you're converting it, because data then has to be converted into reports and dashboards and insights and intelligence, and how it's being consumed, because depending on who the user is, you need to consume it differently. Now, this makes it look like it's a very clean, simple process, and obviously it's not, because what typically happens with these is there is a lot of confusion. And a confusion because of some of these things. The data is often dirty because things don't add up from one system to another. It's often missing because there's a change of system and we didn't migrate data from one place to another. It's siloed because we're using different platforms. It's fragmented because the IDs don't match, project IDs, org IDs, you name it. It's complex and messy, and it's huge. So a lot of the customers that we work with globally typically have one or several of these issues. And our advice is typically the same thing. It's about making a start. And the start can be wherever you want it to be. But there is a bit of a data journey here, right? And the journey usually starts with reflective. It starts with looking at what happened in the past and using things like baselines and benchmarks and lessons learned. If you're using your current data for historical analysis, the next thing that literally every single customer and organization is doing these days is the descriptive bit. What is happening now? This is your real-time reports and dashboards. Where it gets really interesting is when you start to move to the diagnostic bit, where you go, why is it happening now, right? You're understanding root cause, you're doing exploratory analysis, you're looking at what ifs. And what we are trying to do here and talk about predictive, what might happen in the future. So think about it as forecasting, simulations, machine learning. And the holy grail is prescriptive, where you're making recommendations and optimizations, where you're saying what should be done if our predictions come true. So the first two are all about reports, dashboards, analytics. They use structured data. But where we see more and more of the industry going is on the right-hand side. It's advanced analytics, it's machine learning, AI, deep learning. And if you're thinking, are we really doing that? Think about it. Are you using unstructured data? Are you using data in text, in images, in video? And that's when you know you're on the journey. Almost everyone is doing this now over the last 10, 20 years, and there is a lot of room and scope for improvement. But at the same time, I honestly think that we need to start on the right-hand side as well, because the left and the right will probably complement each other. And I guess the last thing that I want to leave all of you with is this is a story about people and data because data alone is not going to be able to make a difference. So if we get this right, what will happen is job allocation will be completely redefined because an AI or a machine learning algorithm will tell you what to focus on at any given point in time. It might change what you have planned for the particular day or a particular week. It strengthens cross-team collaboration because as long as you have data from multiple different systems, all of these insights are generated. So the system does not care about organizational silos. And what we've seen in a lot of examples is it breaks down the organizational silos and increases transparency. It transforms how key business processes are executed because there's a lot of data and you start to ask these questions. Why are we doing it like this? If something takes 20 days, why do we keep putting 10 days in our schedule? If we've always got our estimate wrong, why do we keep copying from the last one? It forces a lot of questions. And what it does is it embeds learning into your organization's DNA because there's a lot of learning that are carried in your most valuable resources. And what this does is it forces that on paper, on a screen, in the form of reports and dashboard. And that can be quite powerful. But it also changes the way you will potentially run with all the digital disruption that's going on in the world. And it perhaps opens up a whole new world of possibilities. So I think what I want to leave everyone with is that reports and dashboards have been there for a very long time. There is a lot of data being created. And a lot of people that we talk to are focusing on trying to get the reports and dashboards right. And that's an absolutely correct approach and a problem that's worth solving. But also think about what's next, because you can make a start today. If you've got some data, you can make a start. Let me put it to you another way. Everything I showed you today is actually available in a product. And if you're using Primavera P6 or Oracle Aconex, some of these are absolutely real in terms of being able to use today. So at Oracle, we've changed our mission 2 years ago to this, is to help people see data in new ways, discover insights, and unlock endless possibilities. I hope